Thanks. Can you hear me? Perfect. So, my name is Andrey, and I would like to talk about prototyping with code. It's not a super technical talk, it's more of, what I've learned talk. And this is the plan for the talk. We'll be answering these three questions. Why to experiment? Why prototype? Why is it important? How do we actually implement it? Specifically, some of the code tricks. And the most sneaky question, so what? So what do we prototype? What do we get from it? What are some of the outcomes? And I'll start with a story. In 2012, I've joined this startup called Haymoose. And I joined actually as a Java developer. I used to be a Java developer back in the days. And I joined because it was like a very challenging job. We were writing our own advertisement network, so we had to handle huge amounts of traffic, and it was very challenging and interesting. And the thing is that 6 months later, after we've solved all those hard problems on the back end, and we've built super cool and fancy architectures, the company flopped, just closed. We've done all that hard work and then nothing. I didn't stop there. I went to work further in startups, in outsourcing companies, in large enterprises, as an engineer, as a team lead, and eventually as a product manager, but mostly focusing on startups. And right now I'm on sabbatical and I'm doing these two projects. One is called Code Podcast. It's about generic concepts in programming. And this new project of mine is called Polychops, and it is about helping musicians practice and getting more out of their practice. But getting back to Haymoose, like what happened? Why, we worked so well and the team was great. Some of those people are now senior engineers in Microsoft. Some of them are CTOs in larger companies. What happened? Well, once I looked into what we are doing in outsourcing companies and in enterprise companies, I realized that we are basically doing the same things in startup, especially now with the agile culture being everywhere. We have something like a product person, maybe it's a CEO in a startup or a product manager, which comes up with a spec, and then the spec goes into development, or first to design, then to development, then to QA, and eventually the code gets into production. So this process is the same, but results vary. Large enterprises don't close every 6 months. Outsourcing companies don't do that either. So what's different? And the most important thing that I've noticed is that the context is different. Now, think about it. If you are working on a product, who of you thinks that the product that you are working on has just too many features? Yeah. All right, there are some hands. All right, and who thinks that there is just maybe 1 or 2 features that we definitely need to implement in order to advance the product and to make the product better? A few hands. The thing is that for me, oftentimes when I would ask these 2 questions to the team, those hands that come up, they would be from the same people. So it was like, the same people say that their product has too many features and also they want more features to build. Like, what happened? Where is this coming from? Why is it happening? And the conclusion that I came up with is that outsourcing companies, what they have is that they have the context of certainty. There is a customer that comes to you as an outsourcer and says, this is the spec, implement it in the best possible way, go and do this. And in a startup, we don't have this luxury. Usually, there are just vague signals from the market, and we probably know what we want to build and which problem we want to solve, but not really. But still, we use the same process. There is a product manager that comes up with a spec, brings it to design, and now, or developers, and now build it. And imagine what it is like to be this person. I mean, they have to pretend that they understand the world perfectly and they can foresee the future and know the customer you know, and yeah, they basically most of the time have to pretend because there is a lot of uncertainty on the market. And what we end up with is we end up doing safer bets than we probably could have. And you know, 90% of startups most of the time fail. So I was thinking about this. Is there a better way? Is there something that we can do differently? Turns out there is a way. And thinking about uncertainty in a broader context, I think in a startup we have uncertainty coming from three big places. It's the market, you know, what is our demographics, how big is the market, how much are they willing to pay. The product, you know, what is the problem that our customers have, what is the solution that we can offer them. And the implementation, like can we even build this product? For instance, you know, we know that a pill that will cure cancer probably will find the market. You know, it's not something we need to test, but can we actually create this pill? Is it possible from an implementation standpoint is a question that we need to ask. And so instead of this execution mindset that we are using when building features from specs, I think we need to change our focus and first solve the uncertainty part. So the goal of the research mode, I believe, should be reducing uncertainty rather than implementing an ideal working feature. So think about it in this way. You know, 90% of startups fail. What if we launch 100 or like, what if we launch 10 products and one of them succeeds? That's all we need. That's basically the mindset behind prototyping. Here is an example from my personal project, Polychops, which is, you know, it started off as a metronome, but with a weird interface, a circular interface, and it was, you know, unusual. And I didn't know whether it would help people practice better, musicians, whether it would be inspiring, how would it work even? Will it work with, you know, in a web browser, or should I build native apps? I had all those questions. And there could be a possibility of me just going forward and, you know, creating a spec end-to-end and building it. But instead, I chose a different way. I chose a way of, you know, doing research. And research, when we are talking about research, the market research is usually done just in an Excel spreadsheet and using Google search. Product and implementation research is something else. Here, we oftentimes need to expose something to people, you know, to understand whether they get it, whether we get it, and so on and so forth. And it turns out that the best tool that we as humanity have so far for reducing uncertainty is scientific method. You know, there is, you know, it's not ideal. We as humans have biases and so on and so forth, but this is the best thing we have. So what is a scientific method? We basically come up with a hypothesis, we come up with an experiment, and then we run this experiment and we see whether it failed or succeeded. And prototypes is a way to run those experiments. Basically, prototypes are carefully constructed illusions that would help us verify whether a hypothesis is true or false. Nothing else. It's not a product that we will sell immediately. You know, it's not an ideal implementation. It's just an illusion, like a movie set or a theater stage. And I believe that in order to build successfully prototypes, we have to kind of put our best selves, our technical best selves, on the shelf for a while and, you know, take a step back. Because we as engineers, as designers, as product managers just want to, you know, do the best stuff. Designers want to build pixel-perfect mockups. Developers want to build architectures and so on and so forth. But for prototypes, we kind of need to become rookies again. We want to become beginners. Because experts often make mistakes in uncertainty, in the context of uncertainty. And there is research that confirms that. Because experts, you know, they know what they need to do. Whereas rookies usually don't know what they need to do, and so they seek constant feedback. And this is a very valuable trait. Experts design architectures. Rookies, they are happy with something that works. And this is what we are looking for. Experts approximate in the future, Rookies just live in the moment. Experts have reputations at stake. And so, they're very invested in whatever solution they are offering, and they tend to double down on the solution even if it doesn't work, whereas rookies are not invested. They basically don't care. So to sum up and explain it to a teenage self, instead of being this guy or girl, you want to be kind of this person. Like, I don't know. How do we do that? What are some of the concrete tools and practices that we can use in order to achieve that? Well, I believe the most important part is even before we start prototyping, even before we write the first line of code or build the first video to test something, we need to think about where we will find feedback on that thing that we are testing. Whether we will go online and search for feedback online, maybe, whether we will invite someone to the office. We need to have this in mind. We need to have the end in mind before we start doing anything. And the shorter the feedback cycle, the better. Theoretically, in this company I was working at, Haymus, we did have the feedback cycle. It was just 6 months or whatever, 4 months long, and at the end of the feedback cycle, we just found out that we don't have any money in the bank. That's also a feedback cycle. It's just very long. So what we need to do is we need to shorten the feedback cycle. Here's an example from another startup I was working at. It's a B2B startup that sells the product to kind of large enterprises. What we've built is a piece of software that allows you to drag and drop create mobile applications. And those mobile applications, they extract data in the background from an actual web application. So if you have an old CRM system or an old Salesforce system that doesn't work on your phone, you can build a nice mobile app in a matter of a couple of hours. And it's a nice product, but the thing is that in large enterprises, the sales cycle is at least 6 months. That means that we get to build whatever our fantasy allows us during those 6 months, to just then later realize that it was all just, a dream. We don't need this. And so what did we do? We created an internal team that would serve the customer, but would also build just, random applications that we would find, random use cases. And they would just do that. And that allowed us to have super short feedback cycle because there was a dedicated team that was using the product and feeding us super early feedback. That was great. Another example from Polychops, we started with super early on with publishing videos on Reddit and so on and so forth, asking people for feedback and maybe asking for engagement. So some of the people agreed to have a call with us, for instance, and have a conversation about how they practice, what are the types of metronomes they use, and so on and so forth. And those conversations, they actually yielded great results. And that leads me to the next point. Seek qualitative feedback, because quantitative feedback oftentimes leads to local optimizations. What do I mean by that? Quantitative feedback only gives you an answer yes or no. Is the green button better than the red button? This kind of questions we can answer with data. But qualitative data can the person can tell you, hey, I don't need a button here. This is something that you can automate completely. And this opens your mind to a completely different perspective. One example of a company that is heavily reliant on quantitative data and on A/B testing is Booking.com. I don't know. I think there is space for improvement on the website. Sorry, Rachel. Now, here is a story from one of the people that we did an interview with. So remember, we started Polychops as a metronome application, just a metronome. And we interviewed one person, and they said, hey, can I export the sound of the metronome and have it like as an audio file? We were like, why would you do that? This is so backwards. Like, why would you do that with the metronome? And he was like, no, I just want to put it in a digital audio workstation and then record myself on top of the metronome and then listen back and hear if I'm on time or not. And we were like, wow, this is actually genius. Like, hey, can we ask 15 more people if they do the same. And turns out, yes, people just turn on the metronome, put the whatever recorder app on their phone, record themselves playing, and then listen back to understand whether they are on time or not. And so we were like, hey, we can just build this in the app. Like, you don't need to have a separate recorder, separate metronome. We can show you the beats, we can show you, the waveform, everything, all in one place. So this was super insightful, and we would never get this information with just A/B testing. Like, we wouldn't have even this idea. Now, another important principle is the interface in a prototype is everything. And I do mean interface in a very broad sense. So for instance, in Polychops, the interface is the graphical user interface, but it is also the sound, because the user also perceives the sound in the app. In an API, the interface is your documentation that describes all the methods in an API. Speaking about APIs, in Productive Mobile, at some point we decided to rewrite some of the APIs that we exposed to app creators. And so instead of going the usual way of me as a product manager just specing the whole thing very thoroughly and then giving it to developers to implement, we went a different route. We created a small file with the documentation where all the methods were written and all the signatures were described. And then we took that API and we kind of fake built those apps with the people that were using the application to build actual mobile apps, to build mobile apps on paper, so to say. And all the data that would be processed in the API, we did all the processing also on paper by ourselves. And so we did maybe 5 or 6 iterations before we understood, okay, this is the ideal API. We can actually serve 90% of the use cases that we want to cover. Let's spec it and build it. So we kind of saved a lot of time using that. Wow, I didn't know the sound would work. But this is the very first prototype of Polychops, and is just a video. And initially I coded it in Flash. And it was like, hey, friends, look at it. It's perfect. It's your future metronome. And people said, yeah, we can understand polyrhythms. We can understand 2/3. And I was like, yeah, that's the purpose. And this is how Polychops looks now. And it's not much different. Even though on this thing I spent maybe 10 minutes, and on this thing I spent maybe a month. All right, and talking about faking, we are all taught, especially as developers, to build nice architectures. We are taught Gang of 4 design patterns and so on and so forth. But the thing is that when you're building prototypes, you kind of accumulate a set of patterns that is the opposite of whatever we were taught to do. And this is super interesting. So for instance, in Polychops, we wanted at some point to test multiple users interacting with each other. And instead of building the proper authentication, which is very risky, very expensive, takes a lot of time, you need to test it, you need to pen test it, we just, we said, okay, it's a prototype, we will just save a token or a user ID in local storage, and we will send it with every request, and bam, we have users that are authenticated. We will send them the official memo saying, hey, don't use it, don't put any sensitive data there. But it was enough to test the concept. And kind of over time, you accumulate those kind of patterns, and it's important to think about it as a library. Now, several minor tips. Use a design system, because you don't, because you don't want to spend your mental energy and time thinking through every possible interaction in your app. Certainly, we did this mistake because initially we built the app from scratch and we came up with all the buttons and we built super custom interface. But then we found out that we need to build notifications and menus and parent-child views and drop-downs. And what do? Do you design it all from scratch? No, it's just easier if you use something ready-made. Material is a good example, at least, of way of documenting stuff where everything is very clear. You can take it and use it. Steal. No, seriously. Don't steal from your competitors, though, because whatever they've built, they probably have already tested and it probably works. You don't need to prototype it. It works. Just copy. But steal from other industries, from parallel industries. So for example, this feature with recording and playing back was heavily inspired by digital audio workstations like Logic and Ableton and so on and so forth. But it's massively simplified. So you don't just copy it one-to-one, but you steal a lot of ideas. You will go into depth, especially as engineers. And it's okay. So one example of it is we are all taught this don't repeat yourself principle. God forbid you copy-paste the code 2 times. Oh, no. While prototyping, I've noticed that I have a rule that I copy the code at least 3 times before I abstract it out and create an abstraction on top of it. At least 3 times. Why? Because over time, you see that the code diverges. Something that you saw that is similar is actually different. And after you've copied the code maybe 3 to 5 times and you see that it's completely the same, then you can abstract it out and create something on top of it. But the good thing with copying as well, even if they do diverge, but maybe just a little, your shape of abstraction is super clear. Because okay, I just need these 2 parameters that are custom and everything else is the same. I know how to build my abstraction. Because we don't refactor and because we don't have specs, just don't write tests. Don't bother. Seriously, you will throw them away. Now, if this slide would be taken out of context and go on Twitter tonight, I know all your faces. Right? Abstract out libraries and frameworks. This is the only thing that you probably do want to abstract out. Because, for instance, something we did in Polychops is we started using Redux because we had a lot of logic on the front end with all those metronomes and stuff. But then we understood that it would be safer and faster to sync some of the data with Apollo and GraphQL. So we had 2 competing frameworks in the same prototype, which is a huge no-no. But we could do that because our dumb components didn't know about the wrappers. They didn't know about where the data comes from because all of this stuff was abstracted. Another example, we kind of got used to making folder structures that are following a framework, such as, we have action creators and reducers and middleware files or folders. Well, this is something you also want to avoid. I mean, generally in development, but especially in prototypes, because what you want to do at some point is maybe to switch the library or take it away completely. So it's a good idea to maybe think in terms of your domain model rather than the framework structure. So for instance, in Rails, it's very strict. You have to use the controllers and stuff like that. I mean, consider maybe not doing that if you will switch at some point. Right, but do not go bankrupt, especially under pressure, it's very easy to do. You show a prototype to your boss and they're like, oh, okay, great, it works, let's push it into production. Like, no. Be clear with your superior officers or whatever that this code is a prototype and it's not an actual thing. It will help you to validate your hypothesis and to experiment and to understand the direction, but it's not production code. So whenever you decide that experiment succeeded and you want to keep the prototype, just come back and rewrite it. And now, but then, we are borrowing the time from the future. Why do we even bother writing, bad practice code if we will rewrite it? Well, the thing is that a lot of experiments, or some of the experiments will fail. And so some of the code you will just throw away. Or maybe some of the experiments will show you some inconclusive results, but they will definitely point you in the right direction, and you will have to maybe rebuild something differently compared to how you did it in a prototype. So we still get some value there. To sum up all that was said so far, we have 2 contexts in the company. We have the context of certainty and the context of uncertainty. Certainty is when your customer in an outsourced company comes to you and says, this is the spec, implement. They have already resolved all the uncertainty. You don't have to resolve it. Uncertainty context is when your product manager tries to guess which feature would best serve your customers. And in those 2 contexts, we have 2 different mechanisms that we can use. In a certainty context, we just go for implementation, best code possible, best mockups possible. In an uncertainty context, we go in the opposite direction. We want to do research. We want to do exploration. And so we want to also embrace different mindsets. You know, we don't want to be hardcore designers or developers or product managers when we are in an uncertainty context. We just want to explore, we want to be open-minded. So what are the results? You know, show me the money. So I think before I talk about results, I think it's important to mention that what I'm talking about right now is decision quality. I'm not talking about outcomes so far. An example is, you know, because we are dealing with uncertainty, we can just guess one time, write a spec and be right and get huge output from that. But maybe the probability of this was initially just 10% and we got lucky. Or we can do all the best possible research and we can just, with the probability of 90% of success, we got into the rest of the 10% and we failed. You know, so I think it's important to think about decision quality versus the outcome quality as well. But talking about outcomes real quick, which is not as important. For instance, in productive mobile, after we speed up the feedback cycle and we've implemented all the changes, the platform started covering maybe 90% of use cases instead of initial 20. And those 90% of use cases we started covering in a matter of days rather than weeks. So, you know, it's a huge improvement. And what's the most important thing about that is that we didn't implement maybe, you know, on average 5 specs every half a year. So those specs, we just, you know, we experimented, we explored them, and we understood that we rather don't understand them, or we don't understand the customer, or, you know, something is off. And that is actually a huge win. We didn't do some work, you know, it's great. All right, I think I don't have much time, but if you are willing to talk to your stakeholders, and if you want to understand how to sell all that approach, there is some information in the material, in the article that I put after the talk. And I hope you will get to apply some of those learnings, and I hope you will build great products, and at some point, I too will be one of your happy customers.